Hey everyone, welcome back to the channel. If you are new here, I am Frederick and I do create content about .NET. In our previous videos, we have explored configuring YARP API gateway and adding caching to it. If you haven't seen those yet, I highly recommend checking them out. The links are in the video description. Today, we are diving into two powerful features of YARP API Gateway that can significantly enhance the performance and flexibility of our microservices. They are load balancing and request and response transformation. Let's first talk about load balancing. Why do we actually need it? Imagine your application is growing and the number of users is increasing rapidly. With a single instance of your service, you might face performance bottlenecks, leading to slow response time or even downtime. That is where load balancing comes into play. Load balancing distributes incoming requests across multiple instances of your service, ensuring no single instance is overwhelmed. This not only improves the performance and reliability of your application, but it also provides fault tolerance. For example, if one instance goes down, the load balancer can redirect traffic to other healthy instances, keeping your application running smoothly. Let's relate this to an e-commerce microsystem. Let's say you are running an e-commerce platform with high traffic during sales event. By implementing load balancing, you can distribute the traffic evenly across multiple instances of your product service, ensuring a seamless shopping experience for your users. So let's see how we can integrate this load balancer in our API gateway. So I have created a project already and created a blank solution, added 3 projects, API gateway for one. That is where we are integrating our YARP reverse proxy. And also we have our other API and our product API. These services are doing not much. All that they are doing is to return one endpoint in their controllers. So you can see from this order, it's returning an order. Just a hard-coded order here in the form of a list. And when you go to the API, it also returns a list of products. That is what we've done so far. And when you go to our API gateway, we installed our package, that is a YARP .reverse proxy. Aside from that, we made a configuration, and in the configuration, we use a class, or you can use the configuration file in the app settings. You can also use that. So let's see how we can integrate this load balancer. With the help of YARP reverse proxy, configuring load balancing is quite easy, very easy, and you can do it easily. See, now from our configuration that we created, we want to put them in here. So you can see that in the configuration, when you go to the route, we have this route in the form of a list, and that tells you what each route here is mapped to in the clusters. So you can see each is having a unique cluster ID. So this is a product cluster, and that is the cluster ID for this. So it means we have to map it in there, and that is exactly what we are doing here. So you can see we have a product cluster, and it gives you the destination. Now, in order to create or add a load balancer, this is just an instance of your application. Let's say this is an API. So what if in case I want to have a multiple instances? Yes, I can do it. That is the reason why this here is a dictionary. So it can handle a lot of lists in there. So you can see that from here, when we check, we have our product API, which is running on port of 5001. We have other cluster, that's an other API, which is running on the port of 5002. Now, when we check from this service, that is API gateway, when you check from the line settings, this also running on, that's an HTTPS of 7000, that's 7000. So it means we can create an instance of each service that we want to do. Let's go back again to our basic configuration. Now, in order to add this load balancer, let's say let's assume you want to increase the instances of our product. So in that, all that we're going to do here is you go to the cluster, and that is where we have to add another configuration for that. So here, let's make 2 other instances. So let's make duplicate of this. And since we have 501 for product, 502 is for order, we need to make this as 503 and now 504. So here we are creating an extra 2 instances. Okay. Now here, after doing this, all that you're going to do again is to add or integrate this load balancer. So then have your load balancer policy. And now here this equal to, you're going to have this load balancer policies. Then let's use round robin. So we have our policy and we are using this. So round robin is a built-in policy. There are a lot of built-in policies in there. So when you put in dots, you're going to have all these policies. Default one is a power of 2 choices. Now with each policy, what does each do? Now when you pick this first alphabetical, so you can see we have this first alphabetical. What it does here is select the alphabetically first available destination without considering load. So it's going to use the alphabet in order to get it selected. Whether it is loaded or not, it's going to use it. We don't want to use that. Aside from that, you can also go in for random. And now with this random here, you're going to pick it randomly and assign the request to it. Okay. But in here, you want to use this round robin. Round robin here is select destination by cycling through them in order. So they're in order, and I'm going to cycle through them, and that is where you're going to pick this destination. Okay. So we have also list request that you can select. That is, select the destination with the least assigned request. So let's say we have 5 requests in there. Now 4 of them have gone to one instance. Then the other one coming in will go to the one with no request received. So that is the list request. So you can choose any of them based on what you want to use it for. But for now, let's maintain this round robin. Okay. So that is all we need to do in here. The next thing to do here is we need to run our instance of this application in 3 different console, right? So let's save this. And actually I have my PowerShell or terminal. Let me put it up. And in here, we're going to run this through this port. Okay, so before that, that is a terminal. And let's navigate. So I have this. Navigate to this project root. So that is I have in project. And in here, whilst I'm in this project, so when I go to, that is a project name. So I can grab this project name, then go back. And in here, if I type in ls, I'm going to see our project. So I want to run the product API, because when you check here, we want to load balance the product API. So let me grab this product API. And okay, so that is cd product API. So you can see from here, I am into the root of this product. Now, all that I'm going to do here is I'm going to use .NET run, then -- URLs. And in here, I'm going to specify my URL that I want to build with, I want to run with. So that is HTTP, and I have a local host. Now, this local host, the first port here, it is a 5001. So 5001. And that is what I need. So I can run this instance in here. Now it's first going to build this, and after building this project, it's going to make that run. When we are done, we're also going to run this another instance. So we need 3 instances here to make sure application is running in 3 separate instances. Yeah, so you can see that this app is running. Let's also run, because we need to have 3 instances. Now the next one here is a 503 and 504. So let's also have another 2 terminals to handle that. Okay, so within in here, let's also run the same thing. And this will run on HTTPS, localhost. And now the port here, it is 5003. So we're running on this. We can also run on another instance. So we have it in the 5004. And we can have .NET run, then HTTP, we have it localhost, then the port here is 5004. So it means this is not running. We have to do this again. Let's try this. Okay, so let's do it again. And yeah, so this is running also. And this also should run. Yeah, the same. Okay, and let's try this. And it's also running. So we are having 5001. We have 5003. We have 5004. You see? Now let's put our browser and let's see how we can get access to this. So we have our local host. Then it is 5001/swagger. When you access this, we must have access to our product API. Let's also copy this, change this to 5003, and we must also have access to the same product API. Then let's have 5004. So with this, we are scaling our app manually, right? So we have 5004. So we have 3 instances here. Now with these instances, the load balancer is going to now balance the load, the request to each of these. Now, in order for us to test this out, let's make sure we have our postman active. So we can make a call. If you have any other Insomnia or any other software that you can use to test it, it's possible. You can do it. Now we have to make sure that our gateway is running. So let's create another instance in here. And now let's make sure our API gateway is also on the move. So let me go in there and grab this. So ls gives you API gateway. So you can see we are in. And let's also have .NET run. And now this is running on the port of HTTPS. And that is a local host. And do you remember the port 7000? So let's run this. So we have an issue in here, bit field. We have to fix it. Let's check and see where we need to do that. Alright, so sure, that was a problem. I believe you've configured yours, isn't it? Yeah, so let's try again. We're just going to build it and run it on the port that we specified with the protocol of HTTPS. Whoa, still? Okay, so let's build our API gateway. Alright, so built, and let's try it. So let's use .NET build. Okay, so this is built. There's no warning, no error. Now let's run this. Wow, and now this is also running. So we can just grab this. Let's go to our browser. And then here for our API gateway, we know that this HTTPS, the localhost, and this is running on the port of 7000. So when this runs, we go see nothing. Yes, but it's running because we have the port in here. That is a 7000, and that is exactly what we haven't. So this is running. Now let's use our Postman to check this out. Okay. Now before we check out, we have to make sure our console is even here, because that is what you're going to see which port is the load is balancing to. So let me put this one here. Then this should also, okay, let's make it here. Now we're going for product. So the first time we're going to make a request to product, click on send, and now let's make sure, let's check here, it is picking up to what, 5001. So this is the first port. Now this port here is going to return the content. So let's wait and see. It's going to delay for 4 seconds. Since we introduced caching, we introduced delay. The next request is going to cache it. We did this in the previous video. So let's see. Okay, so we have the content in here. Now the next call that's going to make, let's see. So it took 4.78. Now the next call, let's see, you can see cache is working. So it did not even make a call to this. But unless the time period has expired. So in order for us to test it well and see what's actually doing, let's go back to our settings and let's deactivate this caching. So let's go to our product controller, and in here we want to, let's clear the delay because it is a product control API. So let's save that. Aside from that, let's go and stop the caching. So we can do that from our program. That is our API gateway. Then in there, here we can just copy this. Let's map this. And let's comment this. Okay. So now that we are done here, it means we have to go and stop and restart all, even the product, because we've done new thing. So let's stop. Let's stop. Let's stop. And I'll stop this as well. Now let's run this again. So run this. 5001 is going to build this, and I get it to run. Let's wait. Yeah, so this is running. And now let's also run this. Okay, so this is not. Let's stop this first. And let's make sure, okay, this is running. Now let's go and run this. This also running, and let's go back and run first one. This also running. Last we're going to run our the API. So let's run this with the port of 700. Yes, so this is now active. Now let's make sure our API gateway console is here, and let me open it wide. Then let's put our Postman. We're going to make a call to this. Check it out. Now the first call is going to get hit, sent to 5001. I hope you've seen that. Let's make the next call. And now here it is 5001 again. Let's try this again. The same 5001. So we are still getting 5001. It means it is making this request to the first service, but not the other ones. Why? Let's go and check whether we using the configuration. So let's go to the program. Yeah, that is this one. And you can see from here, we are using the section, and we haven't added the configuration, that's the load balancing, to this section. So let's comment this, and now let's use the class file that we created. That is where we are having this basic configuration, and that is where this load balancing resides. So let's save this. And again, we go to the PowerShell for our API gateway. Now let's stop this. Can clear screen, and now let's run this again. So we are having an issue here, and what is the issue? It is saying that an item with the same key has already been added. Let's go to line 40 of our basic configuration. So line 40 in here, basic configuration, and line 40, that is this. Okay, so we're going to return a cluster config, and here we have a destination with multiple instances. Now, yeah, so this one should also have a unique. So let's make it destination 2, destination 3. Great. Let's make sure we get no errors again. So let's run this. Yeah, so this is running. Now let's go up. Let's go to, and in here, let's try to make a request. So let's first see where the request will be sent to. Let me open this more. Okay, so I click on this. It's going to make a call to the 5003. Have you seen that? Now let's see another call. It is getting to 5001. Great. Another call, 5004. So you can see that we've shared 3 requests shared among these 3 instances. Now the next request, let's see which one, 5003. It's going to start again. Then we have 5001, 5004, 5003, 5001, exactly, 5004. So you can see that it is circling this, circling the request. So start from the 5003 up to 5004, then it starts again. So here it is evenly sharing this request. And it does that to stop overwhelming one request or one service with multiple requests. So you can see this is the simplest way of integrating load balancing in your YARP reverse proxy or your YARP API. Okay, so let's see, that is how to do that. Now let's talk about request and our response transformation. So why do we need request and our response transformation? Now, in microservices architecture, different services often communicate with each other. However, they might have different data format or require specific headers. That is where request and response transformation becomes essential. Request and response transformation allows you to modify the incoming request and outgoing responses. So you can add or remove header. You can even change the body or the request body, or even transform the response format. This flexibility enables seamless communication between services, even if they have different requirements. Just consider this, where you have a front-end application sends requests in the JSON format, but one of your backend services requires XML. In this case, how can you do it? With request transformation, you can convert the JSON request to XML before forwarding it to the backend service. And this can be done in the request and a response transformation. Let's see how we can integrate this also in a YARP API gateway. So let's close this one because we are done. Let's close all. Okay. Now the next thing to do here is, we want to create this in a class, a service class, so we can call that or inject it in the API configuration. Okay. So we don't want to scatter this file with a lot of code. So let's go and create a separate class to handle that. In an API gateway, maybe we can add maybe a folder. I'm sure. Yes, a folder we need. Then with this why I name it folder. I wanted to name it at services, but it came as folder. Right click on this, let's add a class. And with this class, give it a name, any name at all. But well, since it's going to be a request and response transformation, I can do that and add a service to it. So I'm going to say request and transformation. Well, request and response transformation service. Too long, never mind. This is going to be a service class, so it should be a static. Then in that, let's have our public static. And it's going to return iService collection. So let's say this is request and response transformation service. Now I'm going to add this service. Okay, now this needs a parameter, and that's going to be iService collection. So it has been popped up, and that is all. This is what we need. So no problem. We're going to click on that. Now at the end, we need to return the service. Okay. Now what do you need to do? We're going to be adding. So we're going to say services.add reverse proxy, because we have it already installed, so we can also get it from here. Now with this reverse proxy, the next thing to do here is we want to get not even add, load from memory. And now in here, maybe we still need the, let's use the section. So maybe we want to, so let's use load from config. And now that is a builder.services. But when you do that, it means we need to use iConfiguration. Then we say this is config. So in here we are saying that config.get section. And now with this get section, what is the section name? That is an API gateway. Okay, when you go to your solution, you go to your app settings. The name here is an API gateway, and that is exactly what we need to grab. Okay, so let's go to our service, and it is the same. Good. So now that we have this set, the next thing that we're going to do here is we can add the transformation. So you say add, we have transforms. So add this transforms, and now let's have an option builder in it as maybe builder. Then we're going to open this wide. So here, this transforms, you can add requests and a response transform. Okay, let me close it before it becomes too late for me. Okay, so here we're going to say that this is going to the API controller. So there is a request. So this is request. And on this request, it is going to the API controllers. So we're going to say that this builder dot add, you can see that. So we can have request transforms. So we have add request transforms, and in that, let's have as transformed context. Transform context, and within it, that is where we're going to do our magic. So what do you want to do? Let's say add or modify the request header. So here we're going to add or modify the request header. The request that is coming in, we want to modify the header. So we can say that transform context.http context.request, and we have that. So we can say .headers, and on this headers, let's add something in here. We can say that this is X maybe a modifier. Okay, and we say there is a header. So there is a key that we are assigning, and now what is the value? We're going to say that this is maybe Netcode-Hub. So here we have been able to modify the header, and aside from that, we can also rewrite the request path. So we can also rewrite, if you want to change the path, the request path. So the request path here, it is actually going to hit the API endpoint. Let's say you want to register, it should be an API/register. And here we can also change it. So maybe we want to register, but at the end of the day, we want to sign up, or we want to log in. You see? So we can change the path. And now this, since it is now going to enter the controller, as soon as we write the path, is when it gets to the controller, it's going to the path which has been rewrite here, not the one the client sent. So it's very powerful. So we can say the same transform context.http context.request, not the response dot request. And now with this request, we can say dot add, so request. Then we can have headers, you see? So headers dot add, and now in here we're going to have X, that is a forwarded path. So forwarded should be in code like this. So X dash, you have forwarded path. And now with this, we can have a look. We can say that maybe this is a new path that you want to pass it on. You see? Then we can terminate this. So, one beautiful thing about this reverse proxy here is it exposes its own proxy request. So instead of using this HTTP context from here, we can get this proxy request, so we can add this header to it. So we can say this is proxy request. And now in that, we can get this header straight ahead or straight away from that. Okay. Now, aside from that, we can also maybe we can launch, or we can log. We can do login. So let's try that. So you see, you can manipulate this. So let's say log. You can log request details. This will be optional. You can do that. So how do we do it? Let's write something. So we're going to say that this is our request that we're going to get, and we can have transform context dot http context then dot request. So we have this request. Now we can console the console.write line, and now in here we can specify request path. So let's say this is our request path, and in here we're going to make sure we have this request that we have stored. We can get path from here. This is quite simple. Let's terminate this, and at the end we need to return value tags dot complete. Okay, so that is a way. So you can do a lot of stuff in here. In between, you can do some magic in here to modify the request before it gets to the controller or the API. Now, after it gets to the API and I return to the user, let's catch it up in the way and I modify the header before we push it up to the client. Okay, and in that, we can also do same from here. So you can see we are adding. Now here, let's give it a comment. So this is going to the user, or this is going to the client. Okay, now with this, what are we going to do here? Let's also modify the response header. So we're going to say, so the same builder dot add response transform. We can also get response transforms in here. So add response transform, and now let's have transform context we also close this. And now at the end, let's return value tags.completed task. Okay, then in here we need to add maybe a header. So let's give a slight comment. So add or modify the response header as well. And in order to modify that, we can have this transform context that we have in here. Then we can say that .http context as we did. Instead of going for request, now we're going for response. You see? So response, and now with this, we can also get headers from that. So .headers, and now this header, let's add maybe as this a custom response header. And now what is the value that you want to assign to? This is a custom header included. Okay, now aside from that, we can also log something. So we can also log response detail. And we're going to say console.writeLine, and maybe response has been modified. We can do anything. You can pass in anything that you want to do. So has been modified. Okay. All right. So now response is modified. I think so. Okay. So that is all we need to do. So we can actually intercept it. We can configure or modify the header, the request, and also the response. So how do we check this? Maybe you can create a simple middleware handler to handle this, or so we can check. So maybe in here, the same service, let's create another class. Now this class, I'm going to say this is checker or interceptor. Well, so interceptor. Now this interceptor here, what is it going to do? It's just a middleware. So we have a request delegate. And now this is nest. So let's have public is an async, a task, and it is known as invoke async. Now this takes in HTTP context. We say this is context. And now in here, we're going to have await nest.context. Okay, so this is going to be, this is the incoming, and this is going to be the outgoing. So this is the actual console. This is going to call the next middleware. So as soon as it gets here, it means it's now returned to the user. We have incoming and outgoing. Now let's see. So how do we use this? Let's copy this. We go to our request service, and now down here, this is our iService. Let's have a public static. Then here is going to return an application builder. We say this is use RR service. Then here this takes in application builder. So this is app. And at the end, we want to return app. Then we have app.use. We have app.use middleware. And now let's specify the interceptor middleware that we created. Okay. So in order to use this or make this work, we need to grab this. We go to our program file in here. Let's comment this. And then all that you need to do here is to include builder.services add. We have our request and response transformation service, which takes in configuration. So we say builder.configuration, and that is all. When you come to the middleware, we're going to say that app.use RRS. And that is all. You see? So let's have a look and see whether our request and response was actually modified. So we have an API. Let's make sure we configure our startup project. So multiple projects. Now start this and start. Let's start all together. Okay, so now this is ready, and let's try this and see. So let me bring my Postman. Now when I click on make request, yes, it is hit. Now it is going to the controller, and that is it. So here we have a return response. Now let's configure it out and see whether our request and our response has been modified. So in the context, from here we can extract our request and our response. Let's first check the request. For my request, we go to the headers, and I can see from here we having this X modifier header, and that's a Netcode-Hub. So you can see we have the request being added in the request header, getting to the controller. So in the various controllers, we can extract this header key from it. Aside from that, let's also check it again. Let's go to our response. And from our response, let's go to headers. And we see from headers too, we have this header also added. And that is a custom header included. So in both ways, we've been able to modify the request and the response. But I think one issue is we did not see the path change, right? So let's go to our request. And by all means, we can still use the path which has the get and now set accessed. So we can go in there and rewrite that. And we can do that from this transform context.http context.request.path. Now this path has get and set accessed. So you see, we can set it. We say this equal to new path. Let's save this and let's rerun this again. Check it out. Okay, so let's make sure they are in there. Now let's go and make another request. Click on send. This gets hit. Now continue on. And now in here, let's go and check if the path has been changed. So from our request, yeah, so you can see from here, the path has been changed to new path. So you can see we requested product API/product, but the path has been changed here using this transformation. So that is a way of transforming the header and also the request in reverse proxy, using that in our API gateway. So by integrating load balancing and request and response transformation in your YARP API gateway, you can enhance the scalability, reliability, and also the flexibility of your microservices architecture. These features help ensure that your application can handle increased traffic and facilitate seamless communication between services with different requirements. Do not forget to watch our previous videos on configuring YARP API Gateway and also adding caching to it. The links are in the video description, so you can check them out from there. Stay tuned for more exciting content on microservices in .NET 8. And if you find this video helpful, make sure you like, share, and subscribe. See you in the next video.